Let's talk about the heart of an RV solar system, batteries and inverters. Welcome to part 3 of this 5-part series. I'm calling this a do-it-yourself series, but my hope here is that even if you have no interest in doing this yourself, that you can at least find this information helpful in understanding how an RV solar setup works. In part 2, we talked about documenting your power consumption goals and using an online calculator to get a pretty good idea about the amount of equipment you will need to meet those goals. Your batteries are probably the most important piece of the entire system. That's where all your power is actually stored, and in most cases, they directly power your 12-volt system. They also power your inverter, which powers your 120-volt system. Solar panels really just charge your batteries. Technically, you can power things directly from solar panels, but you'd always have to be sure you aren't trying to use more power than your panels are bringing in. At a minimum, that would cause your inverter to shut off, or it could possibly damage some of your devices. Since your panels are never going to bring in a constant amount of power because it's really always changing throughout the day, you really need batteries to supply a constant flow of energy, not to mention when the sun isn't shining at all. You might have noticed that those solar power calculators we talked about in the last video will typically point you toward a large battery bank and a somewhat smaller sized solar array. The most cost-effective solar setup has enough watt hours stored in the battery bank to supply all of your power needs overnight, plus early in the day and later in the day when the sun really just isn't intense enough to provide much power. Next, your solar array would ideally bring in enough power when the sun is shining again to meet your needs, plus enough extra to recharge your battery bank through those peak sunlight hours. And no more than that, because when your batteries are full, your solar panels don't do much. If you play with those numbers on several of those different solar calculators that I mentioned in the last video, you'll see most of them will give you slightly different results. But the system is always more heavily weighted toward a bigger battery bank than solar array. You really want a battery bank that can last more than just a day, because not every day is going to be sunny, and you won't always be set up at the perfect angle for your solar panels to soak up maximum power. A system that is sized straight from a calculator should account for a battery bank that lasts a while, but I do find that they don't often account for non-ideal solar situations. You'll find that if you've had a cloudy day or two, it might take several days to charge those batteries back to 100%. And as long as you do have enough power to do what you plan to, a well-sized system takes its time recharging the batteries, so you're getting the most work out of your solar panels. I'll talk more about solar panel types, tilt angles, and the effects of weather in the next video. Alright, now that we've covered why batteries are so important, let's talk about different battery types and one last piece of terminology called depth of discharge. Unfortunately, it's abbreviated DOD, which can be a little weird since that's also a government agency, kind of like the abbreviation for our channel. Yeah. Anyway, depth of discharge is important because not all battery types can be discharged all the way without doing some permanent harm to them. In fact, you've probably heard this next part before. Lithium batteries have been available for RVs for quite some time now, and people have been singing their praises for years. Feel free to skip to the next chapter if you've heard all this before, but lead acid batteries, those are AGMs, gel, wet cell. There's lots of different kinds, but the chemistry is the same. These are also those regular deep cycle batteries that RVs always come with. They can't be discharged more than 50% of their rated capacity without doing some damage to them. Lithium batteries, on the other hand, can be discharged almost all the way without issue. I know some of you might debate that and say you should limit your depth of discharge to 80% or maybe 90% discharged, but all of the well-known brands of RV lithium batteries, at least that I'm aware of, that you can buy off the shelf, have their own battery monitoring system built right in from the factory. To get the years of service out of their batteries that they're advertising, the built-in brains of that battery won't let you drain it completely or overcharge it. So I'd be completely comfortable with discharging RV lithium batteries to their full rating, and I do with mine occasionally. Lithium batteries are pretty expensive. They're absolutely worth the price though. One of the reasons they're worth it is because they last a lot longer than lead acid batteries do. They're also much, much lighter. Another thing is something called Peukert's law, which just says that the faster you draw on a lead acid battery, the more power it uses up on top of what you're actually trying to pull out of it. So if you draw a very small amount of power over a long period of time, you'll get most of that 50% rating. If you try to draw a lot of power out of it really fast, it'll go much, much faster than you would actually expect it to. To be completely fair, this happens a little bit with all batteries, but it's much more pronounced with lead acid, and I don't even notice it on our lithium battery bank. Remember in that last video when I gave that sort of dramatic warning about buying some new AGMs and trying to run your microwave off of it and it might make your inverter shut off? Well, that's because of this issue. Drawing a large amount of power from a lead acid battery also causes the voltage to sag really low, and that makes your inverter think something's wrong, so it shuts down to protect itself. They also take a lot longer to charge, so if you can't tell, I really like lithium batteries. All of that being said, you can make a decent battery bank with lead acid batteries depending on your setup. If you're making a small, inexpensive system, or maybe even a medium-sized one that isn't going to put out major power, they can still be an option. Sometimes you can scoop up deep cycle batteries for free, or at least on the cheap when others are trying to get rid of them. If you can handle the extra weight, because it's a lot, they can still be a viable option. But I wouldn't personally recommend them unless you really need to keep your upfront costs as low as possible. I'm obviously kind of biased here, and I want to emphasize that because I just want to present an honest picture of what's out there and really what's available, because there's lots of options. In fact, if you're watching this and you have an RV solar setup that uses lead acid batteries and you're happy with it, I'd really love to hear about your setup and your experience with it in the comments. More and more lithium RV battery brands are appearing on the market. At this point in time, I really haven't heard of any issues with a particular brand, but I would really recommend sticking with well-known brands. I'm probably going to repeat that a lot over the next couple of videos in this series, but I strongly recommend you don't buy knockoff brands for any of your RV solar system components. Even a small setup has enough power in it to start a fire if something were to go wrong due to poor manufacturing. It's really just not worth the risk. That being said, I have seen systems based on used lithium battery banks from electric cars. I think the argument here is that if it was safe enough for an electric car, it would make sense that it's safe enough for an RV. It's a really cost-effective way to get a lot of power storage, and initially I actually thought I was going to go this route with our setup. You do, however, need to be really careful with having a properly set up battery management system. All of the major brands have this already built into their batteries. It stops them from being overcharged, and it stops them from being drained all the way to 0%, which hurts them. It also monitors the temperature of the battery so it can shut it off if it gets too hot, and it won't allow it to charge if it's too cold. A good, properly configured battery management system is a safeguard against a lot of these problems that can lead to a catastrophic failure that starts a fire. So yeah, it's kind of a big doom and gloom warning, but for our setup I sleep a lot better at night knowing that each of our Battleborn batteries has a fair amount of protection built into each one. And no, I'm not saying that those that use electric car batteries are going to burn their house down or anything, but it didn't feel like the right solution for us. Alright, I know this is getting kind of long with the battery part, and I haven't even gotten to inverters yet, but there's still a few more points I want to make about batteries. And real quick, if you've made it this far, can you hit that like button for me? I would really appreciate it. RV lithium batteries are pretty much always marketed as a drop-in replacement for your deep cycle batteries, which is technically true. You can just do a direct swap and be on your merry way. They'll probably charge slower than they should, and if you're going to be RVing in cold temperatures, you might consider moving your batteries to a warmer place in your RV. You shouldn't charge lithium batteries if they're below freezing, and the battery management system likely won't allow that anyway. Our storage bay is heated by our propane furnace, so that's actually where I ended up putting our 6 batteries. Another option is to buy batteries with a heating system built into them, or you can wrap them in some sort of battery warmer. Of course, that does use a little bit more power to do that. The slow charging issue with just doing a drop-in replacement is because the lithium batteries have a different charging profile than lead acid. They like a little higher voltage and are capable of charging much faster. The converter or battery charger that your RV comes with just doesn't know that because it's set up for lead acid batteries. Our original setup had a converter built right into our breaker box from a company called Progressive Dynamics. It turns out that they also make a converter that has a lithium battery charging profile built right into it that I could have bought, and it would have been an easy plug and play affair. I've heard that there are converters out there that have switches on the circuit board that can be changed to change the charging profile, but first you'll have to physically locate your converter and then get the make and model of it to look up what it is and isn't capable of doing. Note though that none of that is worth dealing with at all if you're going to buy an inverter that already has a battery charger built into it, which is actually the route I ended up going. I actually just leave the breaker for our converter off now, and I really just removed the entire thing because it's just dead weight for us now. So we've talked about lead acid and lithium batteries. It's probably worth mentioning that there are other battery technologies out there that are slowly emerging, but at least right now, these are the two main players in the RV realm. Next, let's talk about battery bank voltage. The standard battery voltage is 12 volts. If you watched part 1 in this series, you also know that that's actually a small range of voltages around 12 volts, and the same holds true for this next part. They all actually have a small voltage range because battery voltage always changes a little bit depending on the charge level. You may have heard references to a 24, 36, or 48 volt system. Some manufacturers sell batteries that already operate at these higher voltages. However, the most common way that this is done is by wiring 12 volt or sometimes even 6 volt batteries in series to get the voltage that you want. 6 volt lead acid batteries have been available for a long time, and it's been really common practice for quite a while now to be able to wire 2 of them in series to accommodate a 12 volt RV electrical system. A 24 volt battery bank can be made with 2 12 volt batteries wired in series. You can then add more sets of 2 12 volt batteries by wiring a 24 volt set of batteries to another 24 set volt of batteries in parallel. You can also create all sorts of different combinations this way. The reason for doing this is efficiency. An inverter that uses a 24 or 48 volt battery bank will be a little bit more efficient than one that runs on just a 12 volt battery bank. This becomes a big deal if you want to run high power appliances like an air conditioner. Running a 1200 watt air conditioner through an inverter on a 12 volt battery bank might eat up an extra 100 watts or so due to that inefficiency. By the way, if you want to run an AC off of an inverter real quick, you're going to need some kind of soft start device for that. Anyway, that extra 100 watts turns into heat, and it isn't much fun to have to buy more solar panels just to create more heat on an already hot day. So a higher voltage battery bank is more efficient. Remember in the first video when I mentioned amp hours and watt hours for measuring storage capacity of batteries? Having a higher voltage battery bank makes this a little bit more interesting. It's really common to just say, I have a 400 or a 600 amp hour battery bank. Since 12 volts is just sort of standard, the voltage of the battery bank sometimes isn't even mentioned. But a 100 amp hour battery at 12 volts stores the same amount of energy as a 50 amp hour battery at 24 volts. Or a 400 amp hour battery bank at 12 volts has the same storage capacity as a 100 amp hour battery bank at 48 volts. Just keep that in mind. I personally think it's a little easier to think about it in watt hours. A 400 amp hour battery bank at 12 volts actually has 4,800 watt hours. A 100 amp hour battery bank at 48 volts also has 4,800 watt hours. If you want to go with a higher voltage battery bank for more efficiency, keep in mind that you will need a voltage converter to convert your battery bank voltage down to 12 volts for your 12 volt electrical system. Your lights, water pump, etc. are not going to like 24 or 48 volts at all. Just don't do that. The leveling system for our fifth wheel actually operates on 12 volts and it says it can pull up to 90 amps. The voltage converters that I was finding at the time weren't rated for that high of amperage, so I would have had to wire in more than one. To keep it simpler, I just stuck with a 12 volt battery bank for our setup. It was a compromise. So let's talk more about inverters. They're all sized in watts. From a little 100 to 200 watt inverter that you might see in a car or a truck, all the way up to a 10,000 watt inverter, or maybe more, but anything in between as well. If you did your power audit from part 2, you should have a pretty good idea as to what size you're looking for. Again, I recommend against cheap knockoffs. I used Victron equipment and I've been really happy with it all, but there really are a bunch of good, reliable brands out there. It is always worth reading the reviews though. Next, you'll have to decide how you're going to wire it in. And another quick warning here, please hire a professional to do this for you if you aren't 1000% confident that you can do your own wiring safely. I'll talk about 4 different ways inverters are added to an RV. Again, the sky's the limit. There's way more than that, but here we go with 4 examples. For starters, here is a 1200 watt inverter made by Xantrax. This came with our RV to run our residential fridge from our batteries when we were traveling. Our fridge has about a 900 watt surge when it starts up, hence the 1200 watt power rating. This was wired in such a way that the incoming 120 volts from the campground would first just go through it, and then the output would go to our fridge and a couple of other electrical outlets. It has something inside of it called a transfer switch that just allows incoming power to pass right through it when it detects 120 volts on its input. There are several different settings, but the one I set it to most of the time allowed it to automatically switch over to powering things from your battery if it detected that the incoming 120 volts wasn't there anymore. Like if there was a power outage or you just shut off power so that you can go ride down the road. This would kick on and keep the fridge running. So this is a good, simple option if you have one circuit that you want to power when you're off-grid. It doesn't have to be a fridge, especially if you have a 12 volt or a propane fridge. You could use this setup to power just one circuit that keeps your laptop and cell phone charged. You can also shut this off when you go to sleep to save power. Of course, that's not an option if it's running your fridge. Next, a slightly more complicated option is to wire in a sub panel. This is where your inverter supplies 120 volt power to a separate and usually smaller breaker box. The sub panel then distributes power to what you want it to run. I didn't personally go this route, so I'm not going to speak a whole lot more about the wiring of this particular setup, but it really is a great option and there's a ton of info about sub panels out there on the internet. The next 2 options are on powering your whole RV. If you have a 30 amp connection, this isn't terribly complicated. If you have a 50 amp connection, we'll talk about that next. To accomplish this with a 30 amp RV, you'll obviously want to choose an inverter that's big enough for all of your power needs, but it's also similar to this one right here with the transfer switch in it. Make sure in the specifications that the transfer switch is rated for at least 30 amps so it can handle the full load from a campground. Next, it is wired right in line with your main 30 amp cord to your RV. Power goes in and the output is then distributed everywhere through your breaker box. So when you're at a campground, the incoming power just passes through the transfer switch in your inverter before powering everything in your RV. When you're away from the campground, the inverter is then on and it's exactly the same except that you're now drawing power from your batteries instead of from the campground. Keep in mind that a 30 amp connection at a campground can supply you with about 3,600 watts. You may have an inverter that's only capable of, let's say, 2,000 watts or whatever you went with. Okay, so to accomplish this same setup with a 50 amp RV, you're going to need 2 inverters. And that's because a 50 amp RV connection has 2 separate 120 volt lines that both share a neutral, which is the return line, and a ground. Each side of this connection can supply 50 amps for a total of 100 amps together and a total wattage of 12,000 watts. It's actually a little bit less than that because breakers are designed to pop a little bit before you reach that max current, but it's close. Anyway, we have two 3000 watt inverters. Each one of them has a transfer switch rated for 50 amps. So while the wiring is a little bit more complicated, it works in a similar fashion to the last scenario with the 30 amp RV. I do have to know what appliance runs on line 1 versus line 2. That's the two separate sides of that 50 amp connection. So I can make sure that I don't use more than 3000 watts on one of those lines when I'm not plugged into full 50 amp power at a campground, or I'll end up overloading an inverter. The other interesting drawback to this setup also comes with a bonus in a way. The only way my inverters work together when they're semi-wired together like this is to work in something called a split phase configuration, meaning that line 1 and line 2 still operate at 60 Hertz, but they're slightly out of sync with each other, which makes absolutely no difference at all for powering appliances. But the inverters are now a little bit more picky about what kind of power they let into the RV from the campground. I can no longer power both line 1 and line 2 at the same time from a 30 amp connection with an adapter. Now, when I do that and I plug my 50 amp RV into a 30 amp plug with an adapter, my inverters only allow incoming power to go to line 1. Line 2 is then only powered by its inverter, which means I still have to watch how much power I use through that inverter. And because both of my inverters also charge the battery bank when we're on campground power, appliances on line 2 will draw down the batteries while the inverter for line 1 recharges the battery bank. If that sounds a little goofy, it is. The bonus of being configured this way means that if we're visiting friends or family and can plug into just a 15 amp household socket, we can still use all of our appliances as long as we don't overload an inverter. Then if we've drawn the batteries down over the course of the day because all we had was that little connection, we don't use as much power overnight, so that gives the system a chance to recharge overnight. It's a nice way to be able to get a lot more power out of a small connection. One last thing I wanted to mention here is to check all the info that comes with your inverter. It'll tell you what size of fuses to use and where they go in your schematic. For the next video, we're going to talk all about different types of solar panels, mounting, and making a plan for how it'll all fit.